Let's start with a question most analytical and QC professionals have faced at least once. You generate perfect chromatograms, your calculations are clean, but then someone asks, which standard did you use? That single question can decide whether your data is accepted or questioned. Today, we're going to clearly understand the difference between reference standards and working standards, why both are critical, and how choosing the wrong one at the wrong time can quietly put your entire project at risk. Before we dive deep, let's set the stage. In pharmaceutical testing, reference standards act as the ultimate authority, the gold standard. They are highly pure, fully characterized, and trusted globally. On the other hand, working standards are the practical heroes of daily lab life. They are derived from reference standards and used repeatedly for routine QC and stability testing. The real insight here is this: you don't choose between them, you use them strategically together.
A reference standard is where analytical truth begins. It's a substance with clearly confirmed identity and purity, verified using multiple advanced techniques. When you use a reference standard, you are saying, this is the unquestionable benchmark. From a regulatory perspective, reference standards ensure that your data is globally accepted, scientifically defensible, reproducible across laboratories. That's why regulators trust results generated using properly qualified reference standards. Now let's talk about the working standard, the backbone of routine testing. A working standard is prepared from a reference standard and carefully calibrated against it. Its purpose is simple but critical: to preserve accuracy while enabling daily laboratory operations. Since reference standards are costly and limited, working standards allow labs to operate efficiently without compromising scientific integrity. This comparison highlights an important truth. Reference standards deliver absolute accuracy. Working standards deliver operational consistency. Reference standards are used sparingly and validated extensively. Working standards are used frequently and monitored continuously. A compliant laboratory never relies on just one. It balances both to maintain data integrity and efficiency. Choosing the right standard depends entirely on the purpose of your study. Use a reference standard when validating a new analytical method, submitting data to regulatory authorities, confirming identity or purity of unknown impurities. Use a working standard when performing daily QC testing, running long-term stability studies, monitoring impurities batch after batch. The key is intention. Use the highest authority when defining truth and validated consistency when repeating it. This is where the stakes become real. Inaccurate standards don't just cause lab errors, they lead to regulatory rejections, product launch delays, increased investigation costs, potential patient safety risks. A small mistake at the standard level can create a cascade of failures downstream. That's why maintaining accuracy between reference and working standards is absolutely critical. To protect the chain of accuracy, advanced analytical techniques are used. HPLC confirms purity and impurity profiles. NMR and QNMR provide structural and quantitative certainty. Mass spectrometry verifies molecular weight and integrity. When these techniques align, your standards are not just qualified, they are defensible at a global regulatory level.